The next method we'll look at is called the washer method. And this one's slightly different. Now, we're going to be looking at not only one function, but two functions where we consider the area between them, and then we rotate around. Before, when we took our cross section, it was a circle. However, now we're going to have a hole in the middle of the circle. It's going to look like a washer, hence the washer method. To find the area of a cross section here, we would need to find the area of the outer circle minus the area of the inner circle. The area of the outer circle comes from our top function, which we're going to call f. The area from the inner circle comes from the bottom function, which will be g. So the volume here is the integral from a to b of pi times the top function squared minus the bottom function squared. So it's important to note that f of x has to be greater than or equal to g of x. It is important to distinguish which function is on top. Let's look at this example. We have y equal to x squared plus 2 and 2x plus 2. So this looks like this. Here's our area. First, we need to know this right intersection point, as well as this left one. We need to know our limits of integration. So we have 2x plus 2 is equal to x squared plus 2. Getting everything on one side would give us that x squared minus 2x is 0. And if we solve this, we get that x is equal to 0 and 2. We then have pi times the top function, which is 2x plus 2 squared, minus the bottom function, x squared plus 2 squared, dx. If we square these and then subtract appropriately, we end up with pi times the integral from 0 to 2 of 4x squared plus 8x minus x to the fourth plus 4x squared dx. This gives us 4 over 3x cubed plus 4x squared minus 1/5 x to the fifth plus 4/3 x squared. Didn't quite finish reducing there, but that's okay. Evaluated between 0 and 2. Once we work this all out and simplify, we get 464 pi over 15. Our next example, we have y equal to x squared and y equal to the cube root of x. So if we think about what these graphs look like, here's x squared and here's the cube root of x. We need to know their intersection points. It's pretty easy to see that they're 0 and 1. You can double check that by setting them equal and solving. And then we have pi times the top function squared minus the bottom function squared dx. Squaring these gives us x to the 2/3 minus x to the fourth dx. This will give us pi times 3/5 x to the 5/3 minus 1/5 x to the fifth, going between 0 and 1. Evaluating would give us 3/5 minus 1/5, and evaluating at 0 just gives 0. So we end up with 2 pi over 5. The last example we'll look at, y equal to 3 minus x squared and y equal to 2, revolved around the x-axis. So here we have 3 minus x squared and 2. If we set them equal, we can find the intersection points. That would give us that 0 is equal to x squared minus 1. So these are going to intersect at -1 and 1. We have our top function squared minus the bottom function squared. Once we work this out, we get pi times the integral from -1 to 1 of 5 minus 6x squared plus x to the 4th. This would give us 5x minus 2x cubed plus 1/5 x to the 5th, going between -1 and 1. Once we evaluate this, we end up with 32 pi over 5.